And I'm clicking on broadcast now.
Sure.
Hello, it's Ted Ritzer, the host of the Greening Government Speaker Series. Today we're lucky to have Dustin Bajer speak to us on the topic of permaculture and education. I guess Dustin, one of the things that I was kind of interested in this whole application is looking at how we can kind of make that contact through what you're doing with permaculture in sort of driving home the whole relationship to the land and almost like urban agriculture and food production, and how divorced school children and even adults for that matter are becoming to the environment. So when I saw the description of your presentation that you've done previously, I was really fascinated with how this could relate to greening government and establishing that link to sort of ecological and systems thinking. And I think that's what you can bring to the table today in a different way than maybe we've been thinking about greening government. So Dustin, I'm really fascinated with what you're going to present, and look forward to your presentation.
Yeah, great. Well, thank you for the opportunity. So should I hit share screen here first off? There we go. Hey, so thank you for the opportunity and for everybody tuning in. As Ted just mentioned, this idea of systems thinking, this idea of ecological literacy is really important, and I think there's a few different ways that we can touch on that. One is through gardening projects, urban agriculture projects, but as important, I think, is taking a look at how the education system itself is structured and some of the changes that we can make there. In fact, I'm going to try to argue over the next little bit that we can pattern some of our systems off of natural systems. And these natural systems, of course, have been evolving for billions of years. So there's a lot of lessons that we can learn there. One of the terms that I'm going to be using a little bit is permaculture, and not everybody's familiar with that. And so I've always joked that you can put 100 permaculturalists in a room, ask them to give a definition of permaculture, and every single one of them is going to give you a different definition, but none of them are going to be wrong. And so really, if I try to sum up permaculture design, it is taking a look at patterns and principles of ecology and then applying that into design. So I'm going to show you an example of a school garden that uses ecological principles, but I'm also going to show, maybe make some suggestions as to what the education system could do to encourage these kinds of things. Now, Ted, just to touch base here, I just want to make sure, just want to do like a little quick check, technical check to make sure that I'm coming in loud and clear. It says my sharing is paused. So I don't know if you could send me a message or a quick little thumbs up on video just saying, yes, you are.
Perfect audio and perfect video, Dustin.
Okay, great. That's good to know, because right now it just looks like feels like I'm talking into a screen. So I've titled my talk School Gardens or an Ecological Approach to Education. So I really want to hit on those two topics. I have a lot of content to share, and so I think we'll go through. Feel free to ask questions. There's a little Q&A panel. I should be able to see those, or feel free to type in the chat if you have any questions, and I can try to address those as we go through. We should also have a little bit of time at the end, but just to give you some options. Oh, there we go. Perfect. So to start things off, I want to talk a little bit about systems, and I want to talk a little bit about ecology, how it works, what makes ecosystems so stable, so resilient. Nobody waters, weeds, fertilizes, tills, monitors the insects in an ecosystem. The whole thing can come through and burn down, and it will self-assemble. our education system, or a lot of our systems, are far less resilient than that. And so are there any lessons that we can take from ecology and apply that? I'm going to make the argument that we can do this in sort of two ways. One, in actually designing gardens, school gardens, and the other in actually working with and perhaps adapting some of these principles to the education system itself. This seems like a really strange place to start, but bear with me. The mushroom that you see in this picture here, which I believe is the Provincial Mushroom, and who knew that we had one, and it actually lives on and in the roots of poplar trees. And so the poplar tree here is actually, it's capable of photosynthesis, so it takes sugars, but it gives the sugars to the fungi. And the reason it does that is because the mushroom is able to go out and source water and source minerals more effectively, more efficiently than the poplar tree is, and actually send some of that nutrient to the tree. And so you have two very different organisms sharing resources in such a way that they both benefit. I think what's important to note here is that these two elements, fungi and poplar trees, are very different, are very good at doing different things, and it's because of that diversity that there's some resiliency there.
Yeah, sorry, Dustin. Looks like your slides aren't coming through, so you'll have. Yeah, sorry about that.
Okay, share is paused. Let's go resume share. Hey, how's that? Is that looking better?
Not seeing your slide yet, so just give it a try. There we go. I see a mushroom.
Perfect. You see a mushroom, you see a poplar, and they are sharing resources. Of course, not every forest is made up of, or not every mushroom is sharing resources with one tree, or one tree with one mushroom, but you'll often find little communities here where they're shuttling nutrients around. I don't know if you can see my cursor, can you? And if not, then what I could do is no.
Yeah, it's visible.
Okay, so I'll close this. And so this tree here is actually sharing resources with all of the individuals around it, the tree in the very center, and so it's sharing resources with 8 other organisms. And so if you cut a couple of those connections, it still has others to be able to depend on and to rely on. The kind of on the other end of the spectrum, we have a mushroom on the very bottom right-hand side of the screen that is it's on its own because, well, it's less stable, it's less resilient. If you were to cut a couple of those connections, it's on its own. It doesn't mean it's going to die. It just means it doesn't have that connections, the resiliency to be able to that it can depend on. And if we zoom out to include more animals and more organisms, we start seeing more being shared. So in this case here, you might have a squirrel that eats a mushroom or lives in a tree. The squirrel maybe gets eaten by a hawk. A hawk would also eat songbirds. Songbirds might eat flies, which might also get eaten by fish. We have some fish are in water. Water is connected to everything. And so we have all of these relationships, and it's really starting to look like a web. Now, not every single piece in this relationship is mutually beneficial. The squirrel does not benefit from being eaten by a hawk, but we can say that the more connections within the system, the more stable the system actually is. And if we zoom out further, we end up with what ecologists call a mirror web. Now, this here represents a forest, and every single point in this diagram represents a living or a non-living thing in this system. And so all the lines between those elements are sharing or some kind of relationship, and they're sharing resources. And so it could be one organism living on or in or under another one. It could be one organism feeding off another one. We could have a particular soil type here. We could have a particular, perhaps here's a lake, here's a river. And what you have is a tremendous number of connections. And in this way, you have a sharing of resources. If this is a forest and you go and you were to take a bucket of water and you were to drop that in a forest, that water is going to be used continuously over and over again. It's going to end up in the soil. It's going to end up in a fungi, which is going to shuttle it over to a plant, which is going to get eaten by an insect, which is going to get eaten by a bird, and the bird is going to defecate, and it's going to end up back in the ground, and the whole cycle is going to start over again. And so a single drop of water in this kind of system, a well-connected system, is going to get used over and over again. And so if it gets used 2, 4, 6, 8 times, that is the same as having 2, 4, 6, 8 times as much water. And so in this way, systems really, they compound the resources that they have, because everything gets used more than once. It's effectively the same as having more resources. Here's another network, which is maybe a little bit more related to education. These are neurons. And so what you have is all of these branches and all of these connections. And when neurons fire, they fire in patterns, and those patterns represent ideas and concepts. And so when somebody is learning, they're literally building new branches, and they're literally building new connections. And if you have an idea that is well connected in the mind, and the more branches it has, the more really somebody understands that particular concept. And so education is what you're doing in schools with minds. They're really trying to take the knowledge that they have and add new branches to it, and to expand it and to grow it over time. Here's another system. A lot of people say this looks like the universe or a galaxy. This is actually the internet. And so an internet, another system, every single point in here represents a website, and every single line between these elements represent a link. And so you can move from one website to another by clicking on these links. So we can actually take a look, and we can say, well, where would you want to be if you were a website? Well, right in the middle, you'd have a ton of connections, a ton of links. And so you really want to be at the center of this, because people are going to stumble upon it accidentally. A new website is actually going to show up on the very outside edge, and is going to be connected to very little, but over time, as new links develop, it's going to be pulled in and incorporated into the entire system. That's the same way that people learn concepts. You attach new concepts onto old ones, and you incorporate them into what students already know, and over time, as new links form and are connected to that concept, students remember them. This here is a social network, so this could be a government, this could be a class, this could be a family, and the same way. So if you're in the very center and you're very socially connected, you can get your ideas out there. You can find new ideas very easily. If you're on the outside of this particular network, then it doesn't mean your ideas suck. It just means it's very difficult, perhaps, to get your ideas into the rest of the system, or to get news from that system and bring it out. And so just trying to take these patterns of ecology and apply them in some different contexts. This here is actually a picture of Berlin, which, once again, it has these patterns. There's a really interesting architect by the name of Richard Register who defines cities as places for maximizing connections. And connections, just like in the forest, build resiliency and stability. Now, I want to bring it back to gardening a little bit now that we've gone through a little bit of theory. This here is a picture of Jasper Place High School. And right in the very center of this is our courtyard. And I'm going to share a project that we started there about 5 years ago. And we wanted to put a garden in here, but we didn't want it to just be a standalone garden. We wanted to, just like an ecosystem, see if we could tie it to all of the other things that are happening in the school. And so how can we tie what's happening in the garden to what's happening with admin? How can we take what's happening in the garden, how can we connect it to social studies, or connect it to language arts? How can we connect it to science? Is there a connection with culinary arts? Is there a connection with construction? And the idea being that if we can create a garden that has all of these connections and relationships, then the garden itself is going to be socially resilient. And so that's kind of taking that philosophy of connected systems are stable, are resilient. We wanted to create a garden in and of itself that had those same kinds of properties. In addition, we wanted the garden itself to exhibit ecological patterns. Just to kind of show the counter argument, things that aren't very stable or aren't very resilient are things that have very few connections. So I have the poor panda here, and the panda only consumes bamboo. And so if there's no bamboo, there goes the panda. Here's a gardener in the very center. If you have a garden that only acquires water via the gardener, and that gardener is gone for the long weekend, or if you're a school, the weekend, right, or a holiday, that garden is toast. And one of the challenges with school gardens is that who takes care of them over the summer? So we have to build in the resiliency, build in connections to water into school gardens in order to be able to successfully do that. We have a grocery store down here at the right, and well, there are places in cities, Edmonton included, which we can describe as food deserts. So a food desert is a neighborhood that doesn't have easy access to food. You need to get on a bus or get in a car and drive many miles in order to find a grocery store. But if you have a grocery store and a farmer's market and a backyard garden and a community garden, and your neighbors are growing food, and I think I said farmer's market already, then that is, you're building that connections and resiliency here. And I don't think we need to spend too much time talking about oil, the picture of the gentleman here with bitumen, not saying that oil isn't an amazing resource. It's a fantastic resource, but economically, you know, if you are, let's hypothetically imagine you're a province and you're dependent on one particular resource. If something happens with that resource, you know, there goes that resiliency. And so how can you build that into the systems? So let's take a look at a garden that we put in at Jasper Place High School. This is the first of quite a few gardens that we put in. It's actually one of our smaller gardens, but we really wanted to try to make it function like an ecosystem. We wanted to try to build those connections in it so that it could be resilient. So here's our courtyard at Jasper Place High School. This is 5 years ago. Most of it is concrete. So already, if you're a gardener, you're saying, well, there's not a lot of space to garden, so not that great. But can we use that to our advantage? We have 2 ornamental crabapple trees, beautiful, don't necessarily produce any food, but they are aesthetically pleasing. And then we have 2 patches of sod, which we can use for gardening space. And so what we did is we wanted to build soil on site using waste resources. Literally sent an email out to the teachers and said, hey, bring me your yard waste. And we got, in a very short amount of time, 50 bags of trash, essentially. And we built compost, we built soil from that. We also went to a local farmer and got a whole bunch of straw, agricultural waste. That turns into beautiful, free soil. We did very little tilling. You don't need to till anything. So nature doesn't till, so we figured we didn't have to. And we started working with students from a variety of different grades and a variety of different interests on playing around with sticking a garden in here. What's interesting to note about this garden is it's inside the school. And so all of this material had to be trucked through the hallways, which is in and of itself a little bit of a challenge. This does not look like a garden, but it's the beginning of one. So we took leaves, yard waste, some straw, we took a whole bunch of cardboard, and we layered that into our garden on top of the existing soil to build basically a foot of beautiful topsoil that we're going to plant in. The reason for the cardboard is that it actually, it's biodegradable, but it is actually going to kill the lawn first. And so you put that right on top of your lawn, you throw all of this organic matter on top, and you plant directly in that, and you let the whole thing break down. You'll notice the only tilling we did is we dug a trench along the side. I don't know if you can see my cursor, but here's a trench that goes all the way around. It's all dug exactly the same level. And to go back to that concrete, we're saying, geez, what a wasted space. You know, we can't grow on there. Can we use it to our advantage? And so what we realized is, of course, when it was put in, the engineers and the designers said, well, let's slope the concrete away from the building, and then let's send all the water to a drain in the center. And so the water goes down the drain, or down the side of the concrete, down this lip, and right into the drain in the very center. And so what we decided to do was drill a hole in this lip so that the water would run down towards the curb, run down the curb into the drain, and then fill up this moat. And so that the garden could actually harvest all of the water that landed on site. If this moat ever filled up, it would actually, the water level would reach that hole and the excess water would go down the drain. There's a low impact development the cities are using. You can do this outside and really have runoff water, your streets watering boulevard trees as an example. The next thing we did with this garden is we put in this weeping tile pipe to keep that channel free so that it could fill up with water. And then the city provided us with a little bit of compost to be able to cover the whole bed over, and that is what we planted in. So is a giant, big, spongy mass of organic matter with a couple inches of compost on top, and we planted directly in this. So here's a student, Dragos, and he's planting an understory of strawberries. Now, strawberries are fantastic. We all love strawberries, but the other reason for going with strawberries, they're perennial. So an annual garden needs to be planted every single year. A perennial garden is planted once and you can step back. We really wanted this garden to look like a forest and to have the resiliency of a forest. And so we planted more than 80 species of edible perennial plants in here, things like Saskatoons, rhubarbs, currants, high bush cranberry, low bush cranberry, asparagus, different mints, chives, and we really filled this with a diversity of perennial plants so that really every year you can come in here and you can harvest from it, but if we can get it to look and behave like a forest, we don't need to weed it, we don't need to till it, and we don't need to water it, which is always a major concern. So here's kind of our last step before leaving it for the summer. We covered it over with a little bit of mulch. We even threw a log in there because, heck, there's a lot of connections even with a log. Things live on a log, things live under a log. We did throw a micro irrigation system in here for this first year, just to, which was on a timer, just for a little bit of extra insurance. And this is a few weeks later. So there's a few weeks later. And this here is August without any intervention, so just coming and checking on it. And so we're going from, this here would be end of June, and this here is August without any gardener supervision. So that's just letting it be and letting it let it do its thing. This is the following spring. Remember, all perennials, so no planting necessary. This garden was put in as a food forest, so growing food, but mimicking a natural forest. And all of these plants came back the following year, ready for us to kind of benefit from it, which is fantastic. Now, talking about resiliency, and especially when you're talking to schools and school gardens, is who's going to water it? Well, there's a few different ways to water this garden. One is to actually get out there physically and water it. One is the rain that lands on it, so that's two. We have a tremendous amount of organic matter here, so any of the rain that lands on it is going to stay there. It's not going to run off. We have the passive water harvesting system, so that the water that lands on the concrete is actually going to go into the garden. We have planted weird little mushrooms, and as mentioned earlier, those mushrooms are going to share the resources, one of them being water, and give that to plants in exchange for sugars. We have a micro irrigation system in here in case we have to use it and turn that on if it's particularly dry. And we also have a mulch, which is going to prevent evaporation. And we planted our plants very close together, and perennial plants that have deep root systems. And so they are less dependent on that, the top couple inches of ground soil, because they can actually go quite a bit different. So this garden here, has 8 different ways of either acquiring or holding on to that water. And as a result, since putting this garden in 2010, it's never been watered. The micro irrigation system is removed. It's not something that's being used. And these are some pictures from subsequent years. I have a very vocal cat. And so these are some pictures from following years, all with the food forest. And heading in here and harvesting is a matter of going and checking out what's available, what's ready, picking strawberries when there's strawberries to pick, picking perennial salad greens when there's salad greens to pick, picking asparagus when there's asparagus to pick, and sort of so forth. So that was that first garden that we put in. We've since actually put in a larger one. I don't have any photos of that in the presentation, but our larger garden is probably 10 times the size, and it's filled with, once again, all perennial plants, but we're talking things like cherry trees, plums, apples. We have an apricot in there, 50 rhubarb plants, hundreds of asparagus, and so it's beefed up considerably. But the goal really is to create this kind of a system within the garden. But I want to make the argument that it doesn't have to just be in the context of the garden in which we can apply these ecological patterns. And so there's something in permaculture called the needs and yields analysis, and it's just a tool that we sometimes use in order to look for opportunities to create connections. And so the idea is that every program or every student, every element in a design has two things for it. It has needs in order to function, and it offers certain things in return. So this is our culinary arts program that we have at Jasper Place High School. It obviously needs ingredients, students, professional, knowledgeable staff. It needs funding. It needs people to feed. These are the things it requires in order to function. Now, it yields food. It yields skills, right? It yields credits. It yields ties to the program of studies, industry leaders. Perhaps, I don't know about profit, but certainly for the school, some money is helps go. You know, the money goes back into the general funds. It also produces waste. It also produces scrap food, which we don't have a use for. We could also take a look at some worms. And so at the school, we started composting with worms. You know, they need things too. A lot of stuff that we need: food, oxygen, warmth, other worms. Worms need companionship, right? And it yields more worms, yields compost, carbon dioxide. We could head over to something like some fish. A lot of schools have, you know, someone has a fish tank somewhere: food, water, oxygen, warmth, other fish, and fish yield poo, ammonia, and eventually you got to clean that tank out because it gets gross and yucky. Could yield perhaps a project-based learning opportunity for a student in, let's say, a biology class. In the greenhouse at Jasper Place High School, we started growing plants with the Permaculture Club, and so, you know, plants have needs and yields as well. And if, you know, depending on what you're growing, you can yield food. You could also yield scrap. You could also yield aphids if you got an aphid problem. And each individually, each of these elements are interesting, right? So you have a culinary arts program, some fish, some worms, some plants, and a permaculture club. Those are great. They're nice things to have in a school, but if we start thinking about systems and about forests and resiliency, you know, what if the permaculture club is growing plants to send to the culinary arts program? That in and of itself, right? The permaculture club growing plants to send to the culinary arts program is more interesting than each of these things on their own. But what if the culinary arts program sends their scraps, which remember was a waste before? We had no use for them. So waste is just a term for a yield with no use. So what if we take scraps, feed it to worms, and then feed worms to fish? And what if we were growing fish like tilapia, which we could then send back to the culinary arts program? And so that's what we did at Jasper Place High School. I have a little YouTube video here, depending on my connection, it'll play. But these are tilapia, and they're fed worms and vegetable scraps from the culinary arts program specifically. That's a conventional tank, and this here is an aquaponics, which is much bigger. And the water in this fills up with that ammonia and that nutrient. Once again, it's a problem, right? It's a problem that doesn't have a use. What if we were to take that water and actually pump it through the vegetables to go down? So above this tank here, we have plants, vegetables growing, hydroponically using the water from the fish as a source of nutrients. The water then is cleaned by the plant, cleaned by the bacteria in the plant, and then sent back to the clean in the process of provided culinary arts program, provided so just by connecting those things together, you end up with something that I would argue is more resilient. It's also more interesting. We've removed the problem of waste in the culinary arts program, and we removed the problem of fish waste when it comes to the dirty water. We've even solved a watering problem, right? So watering plants could be time consuming, and you have to remember to do it. Well, if you have fish waste continuously moving through them, we don't need to worry about that. And we've also provided some interesting, I think, opportunities for students to work with the Alberta Program of Studies in a different way. And so it does look, it's not this. I mean, this system is not this system. But it is moving in the direction of being more stable and being more resilient. We can take this same idea, this permaculture approach of needs and yields, and we can take a look at an individual student, and we could say, okay, you know, let's take a look at Johnny and Sarah. What are their needs, right? What are their yields? And this really is different for every single student, right? Some student might need, hands-on opportunity. Perhaps they're kinesthetic. They might need quiet time. They might need music to work. They might work in different conditions, do best under different teaching styles. They may yield exactly what the teacher's asking, or they might yield something completely different, perhaps unwanted. So we have, when a student exhibits behavior that's not wanted, basically what you have is you have a yield that doesn't have a use. And so how can we think about our schools and our students in terms of needs and yields, and how can we start stitching them together to create systems? And so, and if we take that student and we zoom out, we can take the learning environment of a class and we can talk about the needs and yields of a particular class, right? My class might have the different needs and yields than another instructor's as well. Or I might be teaching two classes that are the same, let's say 2 sessions of biology 20, and I might find that actually the needs and yields of my 2 biology classes are quite different. And as a teacher, I need to figure out how am I going to provide them with what they need. A course also has its own needs and yields. And so, this is where we start talking about curriculum as an example. You need to hit those programs of studies and you need to yield evidence, right? So a teacher, you want your students to yield evidence that they understand those programs, that program of studies and those learner outcomes. A school, every single school in every single neighborhood is going to have its own set of needs and yields. It's going to be unique to it. And then the community around it. And so once again, individually, these are interesting things, but like the aquaponics system before, are there ways in which we can stitch our learners and our learning environment, our schools, our communities, and our program of studies in ways that the whole system becomes resilient? And I think that you can do this, and I think that if you're successful at it, you can create something that becomes quite tailored for each student, and it provides opportunities for them really to explore their own passions within the context of the Alberta Program of Studies. And so I'm going to skip over that slide here. The challenge, I think, is that the way that schools are set up are sort of very linear. So traditionally, you have one learner outcome, which leads to another learner outcome, which leads to a third, leads to a fourth. We bundle those together and we call it a unit. We bundle a bunch of units together and we call it a course, right? So it's a very linear kind of process. However, well, actually, if I go back to this for a second, it's a very linear process, but I also think in some ways it's artificial. Let's imagine that the course that we're looking here at is mathematics, right? So you have, let's say, I think a good example would be the quadratic equation, right? Students need to learn the quadratic equation. You have a completely separate course with its own units, its own, with its own outcomes, its own units, and it is solving problems. Let's say it's a physics course, and you're solving a problem that involves the quadratic equation. I think presently what happens is the student in the math class isn't necessarily making the connection that the skills they're learning there apply in the physics class. And so you'll have kids that will literally move from one to the other and answer 50 quadratic equation problems, end up in the physics class. You've changed out A, B, and C with X, Y, and Z, and all of a sudden the problem becomes impossible. And so I think one of the challenges that one of the obstacles is that we've really taken all of our subjects and we've put them in isolated boxes. Teachers also tend to teach one subject, and so they become experts at the field, at their particular discipline, but they don't necessarily know what's happening in, let's say, social studies in English class. The science teacher might not know what those outcomes are, and so they don't see the opportunities to link what they're doing with those other programs of study. Because if we think back to that ecology model, connections create resiliency. And remember, a mind is a system. It is a series of connections. And so if we can connect what's happening in one subject to another subject, then what you end up with is really an opportunity to reinforce learning. And really that's a way of creating resiliency. An idea that's resilient is an idea that is linked in many different capacities. Well, what if you could take one learner outcome and you could say, we can move that in a bunch of different directions. This learner outcome that you're playing with in math, it actually, it applies over here in science class. And, maybe it applies over here in social studies if we're talking about maybe population growth over time and demographics and its effect on societies. And I think the way that outcomes are linked together are really, truthfully, less linear and more system-like in and of themselves. And so I think a program of studies or an education that could follow a pattern or follow sort of a systems approach would really, I mean, ultimately it does mimic the pattern of ecosystems, but in this particular case here, I think when you're talking to a lot of educators, it mimics the pattern of what happens neurologically. I think there's a lot of practical challenges around that. It's very tricky to be able to move through courses in sort of a non-linear way. But what if students could have, say, a passport that has all of the learner outcomes that they hit, and they need to move, let's say, through a high school, and they need to hit those learner outcomes, demonstrate their understanding of them, but we don't necessarily put everything into discipline-specific boxes. That's a pretty big ask, I think, of the education system. But I'm just throwing that out there as some of the directions that we might want to go. I also think that we're able to do these kinds of things too if we somehow reduce the number of learner outcomes. So as an example, in Biology 20, there's 108 specific outcomes. So I know that some of the work around curricular redesign has been going, let's limit that to 10 big ideas. Well, 10 big ideas is a lot easier to connect all of the pieces as opposed to 108 very specific ones. I don't know how much I want to kind of go through this next little section. I might jump through it, but what ecosystems do over time is they increase in complexity. So if you have some stone, you get some lichen on there, and the lichen makes way to moss, and every single little crack and crevice gets filled with soil, and you get a tiny little seed in there, and it germinates, and that seed perhaps the plant flowers, and it brings in some insects. And so what you're getting is you're adding connections. At every single level in succession, you're adding connections. And this is exactly what is happening in the garden that we created. We started with something like this, concrete, and we add connections to it. We create the opportunity for connections, which means we create the opportunity for resiliency. But the same thing is happening within our students' minds. And so what you want to do as a teacher, as an educator, is you want to basically create the opportunity to increase the number of connections there, to increase the resiliency, right? If this here is calculus, right, you need to have all of these other fundamental ideas mastered or have an understanding of them before you can tackle this. But we also want students to be able to think about, we want them to think across disciplines. So how can I take one problem or one solution and apply it in a different context? Can you do that? And I think you have to understand how things are linked in order to be able to tackle those kinds of, what's the right word I'm looking for? Somebody once defined creativity for me as the ability to basically link pre-existing ideas in new and novel ways, thus creating a new idea, which can then be linked to further ideas. And so that is how ideas grow essentially over time. And if we're going to create students who have that ability, we have to think about opportunities to get them to, we have to create opportunities for them to think like ecosystems, right? To really branch out and make those connections. And we don't necessarily do that when everything is kind of in a silo on its own. So really, this is kind of the model that we're looking at. We had a chance to try a little bit of this in 2013. So a student and another teacher and myself came together, and we taught what we called Insight. And so we took the Biology 20 curriculum, and we took the Social Studies 20 curriculum, and we taught that to a group of students all morning. What was nice is that by teaching this common group of students all morning, we were able to blur the lines between those two subjects. We were able to create hands-on projects, many of them around the gardening context, where they could go out and they could explore within the context of those programs of studies. They could do a project, bring it back, and they could say, Mr. Bajer, here's my project. I hit 5 outcomes on this project. 2 of them are biology related, 3 of them are social studies related. And as an educator, I could take a look at that. I could take a look at that program of studies, exactly what is expected of those students. I could give them 5 marks for that one project, 1 mark for each of those outcomes. And we slowly knocked off the curriculum that way. It worked quite well, but it's very challenging to schedule. So we needed basically 20 grade 11 students that were both taking English, or both taking biology 20 and social 20 all morning. And so very interesting experiment, worked very well, very challenging within very challenging to program within the current context of the school system. But it doesn't matter. It doesn't matter what system you're playing with. I think, you know, the main thing that I want to get through, or that I want to get across today, is that connections create stability. They create resiliency. And so when we're talking about designing, be that the designing of a school garden or the designing of our education systems, if we can think in terms of complexity and think in terms of connections, then we really have the opportunity to stitch things together in really unique ways in which those resources, those ideas have the ability to bounce around, and just like that water in the forest, get used over and over and over again, and really create something special. And so I understand I meandered a little bit. I talked a little bit about school gardens. I talked a little bit about curricular change. But I would really like to open the floor up to some questions here, if you have any. I see that there's a couple of comments in chat. Oh, which was about slides. So I don't know if we have any specific questions about any of that. I also have some other photos from gardening projects aside from this that I could share if we wanted to dive specifically more into school gardens.
Well, Dustin, I think it's really fascinating what you've presented, and just while people, you know, we give people a chance to think over what you said, I couldn't help but think in terms of, you know, resilience, and almost going in terms of resilience at an individual person level, and then at a family, and then you look at extended family, and from there to neighborhood and community. And, you know, the concepts that you've introduced, I think, could be applied in a ton of different ways in terms of building resilience. And I know there's a whole international movement on looking at urban resilience, for example, and this whole idea of urban agriculture. And, you know, so I think there's lots to this in what you presented. It's difficult, though, I think, for people to get their minds around what you've presented.
Well, and that's I mean, that's one of the challenges of permaculture, right? And so at the beginning of the talk, I said you could put 100 permaculturists in a room, get them to each define what permaculture is. You're going to end up with 100 definitions, and none of them are going to be wrong, because, you know, when you're talking about systems, you're talking about complexity and connections. And I think that until you practice those skills, it becomes tricky to wrap your mind around them. And it really is about practice. And so for me, when I talk to students about these relationships, especially in the context of a garden, where we're talking about, say, okay, water, how is this thing gonna acquire and or hold on to water? Let's come up with as many ways as possible in this design. They're practicing that way of thinking about resiliency and thinking about connections and relationships. And then I found they're able to take that out and apply it in different contexts. So to give an example, there's one student who I mean, the kid's brilliant, but I was working with him for 3 years, and he ended up doing a permaculture design certificate. He helped design and install some food forests at the school. By the end of his high school year, I almost felt like this guy was as much of a colleague as he was a student. But he's since gone to, I mean, I think he applied for like 10 different post-secondary institutions, everything from education to brewing to horticulture. He also is a second year now apprenticeship at NATE in culinary. He's currently working on some brewing in Olds, but I mean, here's a kid who he's really good at this systems thinking, and so much so that he was seeing 1 ton of waste of grain coming out of the brewery at Olds every single week, which the brewery has to pay to have removed. And he thought, can I do something with that? And so he has talked to the school, which has given him a warehouse and a lab. And he's working with some PhD students on taking that waste, inoculating with oyster mushroom spawn, growing oyster mushrooms, and then the waste itself, because it was mostly cellulose, after the oyster mushrooms eat it, I mean, it can be digested by animals, so it becomes animal feed, but oyster mushrooms also will literally eat oil. So he's been working with land reclamation and oil spills and community gardens for composting, soil amendment for farmers. And so he's just really good at taking that systems approach. And I think, you know, at least from my perspective, I really want to encourage kids to be able to look for relationships. But it's a skill that you have to practice. I mean,
well, that's really interesting, Dustin. There's been a question come in about, has there been an opportunity to really formalize your ideas to be designed in new schools being built? And then another comment related to that, or to have older schools renovated and retrofitted like you did in your presentation? Because, you know, the other comment is this just makes so much practical sense.
Well, I've often think about the physical layout of a school. So as an example, like JP, Jasper Place where I'm at, is 2,400 kids, right? So it's actually the largest school in Edmonton, which in some ways is a benefit because there's so much going on. There's a lot of opportunities for connections and relationships, but the physical space of the school, the way that it's laid out, can sometimes be a challenge. And so even the fact that you have a social studies wing over here, and then you've got a science wing over there, and you have a language arts wing over here, we have a 6-story tower on the one side. And so the physical layout of the school makes it very challenging for teachers to bump into each other and perhaps informally have those conversations that lead to cross-curricular opportunities, because the social studies wing and the science wing are literally a 15-minute walk apart. And so even the way that our schools are structured physically and socially can help facilitate those connections. And so you can play around with the actual layout of the school, where you put teachers, how you share information that can facilitate some of these connections informally within the existing system. And then there's a whole bunch of stuff that could be done at the level of Alberta Ed, where you're talking about curricular redesign. But you know, it's kind of how you said, you can sort of start with your backyard and move to your you know, extended family or the neighborhood. And so you can kind of zoom in and out and look at this at different scales, which is you know, one of the things that you notice in nature as well. It's almost fractal.
Mm-hmm. Well, no, that's really fascinating, Dustin. I'll just ask folks that are listening if they could pose questions either through the Q&A function or through the online chat, because this is a really different way of thinking about stability and resilience at a whole bunch of different levels.
Right. Yeah. Yeah. So really, that's what permaculture is about. It's about systems thinking and applying that to design. And I mean, originally this was applied in gardens in the context of gardening, because I mean, if you're taking a look at nature, it seems like an obvious place to start would be, you know, doing some gardening in the backyard and seeing if you can make it look and function like a natural system. But, you know, more recently, people have been taking these ideas and applying it at the social level, or applying it at larger scales, such as the building of a city. I mean, if a city is a place for maximizing connections, then a great city then, or a great neighborhood, is a place in which you have those serendipitous opportunities, right? Where you can live and work and play and come across new ideas and new opportunities very easily. A poorly designed city makes that difficult. And so, but people move to cities for opportunities, and it's because cities have those connections that makes them somewhat resilient. And so I think that there's room to be playing with some of these ideas on an urban design scale as well.
So there's another question that's come in, Dustin. Do you host training or information sessions for teachers, school boards, or community associations interested in supporting schools in developing permaculture projects?
Yes and no. So I've done a couple teachers conventions, mostly the Greater Edmonton, um, Alberta Central, and I've done the North Alberta teachers conventions where I've done some presentations similar to this one. That's a lot of getting ideas out there, but in terms of hosting workshops to work with teachers in order to implement some of the ideas, that hasn't really been done as much as I would like, and so that's something that I would like to explore a little bit further. I am presently working with Sustainable Food Edmonton on a project it's a pilot project that we've called Urban Ag High, and I think within that we want to get to more of the teacher education piece. And I definitely would like to do a little bit more writing and maybe polish up some of these ideas and get them out into the world.
Well, that's an incredible idea, Dustin. And I guess what I would offer to you is just some an opportunity for some closing comments before we end the presentation.
Great. Well, once again, thank you for having me. Now, I've really, starting gardening project at Jasper Place High School, like I knew I wanted to do a permaculture project. And I knew that permaculture involved thinking in terms of systems, and that the project itself, like the implementation of the garden, should mimic those systems. And on a social level, I should try to tie it into the program of studies in as many ways as possible so I could build these connections. But I didn't really understand at the time the broader application of systems thinking. And so over the last couple of years, I've really kind of latched onto this idea of a garden or an ecosystem as a metaphor for what we could do in the education system, or what we can do in our backyards. I mean, if we apply some of this system thinking there. And so I'm really optimistic about the way that we're going. I mean, I think even 5 years ago, terms like resiliency weren't being thrown around all that much, and now it seems to be at least hopefully not just a buzzword, but we are talking about systems, and we're talking about resiliency. And so I do see these kinds of activities growing. Over the last couple of years, I've been fortunate enough to work with lots of other schools who are implementing these kinds of things. And so, and in some ways, I think that Alberta is uniquely positioned to try some of these. There's a lot of curricular changes that are happening at the moment around redesign. There's some flex time that's that's come to schools, and so schools are playing around with different ways of delivering the program of studies. And so I think it's a really interesting time to be having these conversations around, greening Alberta and greening schools, because the opportunity is right.
Absolutely, Dustin. This has been a wonderful presentation, and it certainly makes you think a little bit differently than we normally do. So thanks so much for taking the time.
Thanks, guys.
Okay.
Thank you, everybody, for tuning in.
Thanks so much, Dustin.
Okay. Bye.
Okay. Bye.